Hello guys, welcome to Pre.Code, and today we are solving this innocent problem, that is power of 2. In this problem we have a number n and we have to evaluate that it's situated in the 2's power or not. For example, 1. If n is equals to 1 and we can evaluate 2 ki power 0, that means 1, right? And if this exists, then we have to return true, otherwise we have to return false. Okay, firstly we can do this question with the recursive approach. So one thing is noticeable: if it is 1, then we have to return 1, because 2 ki power 0, 2 ki power 0 is equals to 2 ki power 0 is 1, right? So it is true. And for other negative number, for other odd numbers, you can see this. We directly get the answer, that is false. If we have 6, then divide by 2, what we will get? 3, and 3 again, no. 3 again, no. Okay. Then if the number is if the number is 8, for example, right, then we have to divide it by 2, and it goes 4. Divide it again, it goes to 2 by 2, that is 2 by 2, that is 1. Okay, then we have to return true, right? So what we can do, we can evaluate if n modulus 2 is equals to 0, then we have to do something. Otherwise, for all the odd numbers except 1, return false, right? And if number is equals to 1, or this number will be modulus, then we can call the same function, that is power of 2. But at that time this number will be halved, right? And and that's it. और ना जरा मलोनी है ते नाल escape करें. Running test cases, wrong answer. Why? Okay, is it work for the test case? Okay, if n is equals to 1, if n is equals to 1, it goes here, n 1 by 2, that is 1 by 2, that is 0. And 0, no, 0 modulus 2, 0 modulus 2 is equals to 0, 0, yes, true, then again 0 by 2, 0, 0, okay, okay. We have to add one more condition, that is, and n must be greater than 0. And tada! Oh shit. Still we are getting the same problem. Okay. Check first and then modulus it. Check first and then modulus it. Maybe it works. Why, bro? 1 by 2. Okay. 1. 1. It's too complex, bro. But we need this condition, right? 0 by 2, 0 by other. If I am not applying this condition, then every time it will uh, put it in a loop, that 0 by 2 again 0 by 2 again 0 by 2. So we have to add this condition, that is n greater than 0, then we can go with it. And if n is equals to 1, then I think print this, bypass it, bro. Maybe it works. Yeah, that's good. But this is not a optimized approach. Okay, I can tell you one more thing. What is the binary of 1? 0, 0, 0, 1. And what is the binary of 2? Binary of 2 is 0, 0, 1, 0. And what is the binary of 3? That is 0, 0, 1, 1. And last but not least, what is the binary of 4? 0, 1, 0, 0. What we are checking? We are checking power of 2. That means a number a number has 2 key power exist or not, right? So can you observe here, 2 key power 0 has only 1 because because what it represent, it represents 8, that is 2 key power 3. What it represents, that is 4, 2 and 1. If number, if we want that number lies in these power of 2's, then it's must condition that we have a one single one in our binary, right? And what is the binary of 6? Binary of 6 is 0, 1, 1, 0. Here, can you see this? Uh, 6 divided by 2, that is 3. This number is also even number, but in this even number we have two ones. That represents that it doesn't uh, it doesn't satisfy our this condition, right? 2 key power 2, 2 key power 1, it does not able to make sense, right? So 3 again divided by 2, no, no, because 3 is a odd number, so we can return false. 6 is never written in a power of 2, right? So what we can do in this approach, all numbers who has only 1 times 1 in its binary and a number above to them, that is this, right? After next we get all these 0 flipped to 1 and these ones are flipped to 0, right? Can you see this? Can you see this thing? For example, this is 1 and we come here. At that time, all the spaces for 2 key power 0 will be filled. What next? For 2, this 1 will be flipped to 0 and it goes to the one next step, that is 2 key power 1. Similarly, here brackets will be full up to 2, 0, 2 key power 0 and 2 key power 1. After all these seats are filled, it goes to the third bit after flipping all the ones to 0. So, so. That is, let's suppose n is 4. And here, this is n minus 1, right? That is 3. N is equals to 4, right? So, what is the AND for these numbers? 0, 0, 1, 1 and 0, 1, 0, 0. What is the AND of this bitwise AND? 0, 1, 0, 0, 1, 0, 0, 1, 0, 0. So, overall answer will be 0. Right? This is n minus 1 and this is n. If the AND operation of n and n minus 1 is 0, that means that n exists in a power of 2. This is the simple condition. If n is greater than 0 and and n no n binary AND of n is equals to 0, that means that number exists in the power of 2. Sorry, I think we are forgot this semicolon, and that's it.